Greetings all. It is June 21st, 2026. Today is the summer solstice. It is a Sunday. So what better day than to take a deep dive into this thing that we call the sun. What is it? Can we understand it? How is it happening? How is it being manifested? So this is going to fly in the face probably of some people's idea of cosmology, and just depending on where you're at in your spiritual journey, most people think they've got it all figured out since they were, before kindergarten. It's basically just a big ball of gas. We're on a big ball of mud, and we're whipping around at, essentially infinite speeds through infinite space and time. So you just kind of throw all that stuff out the window and think you got it figured out. Well, eventually you may start asking yourself some questions, right? These questions right here. Is the Bible from heaven? Is the earth a globe? This was a book by Alex Gleason, late 1800s, I think is when this was written. I've read most of this. I would recommend this book. It's pretty, a lot of ties. You'll see a lot of parallels with today's society and stuff. But really, you're on your spiritual journey and you're going to ask yourself these questions. Is the Bible from heaven? From my viewpoint, obviously, I'm thinking yes. We are all in this creation, created from the Creator, and we're not here without some guidance as to get back to the baseline of truth. Now, you're created, put here with free will. If you didn't have free will, it would be sort of like being in a prison or something. So you got to have free will, and of course that's going to lead you astray, but of course this is going to be here to get you back on track. So I firmly believe this is a yes, and then my comprehension of what's happening here, the way I'm seeing the scripture, this would definitely be a no, even though that the easier way to reconcile some of the movements of the heavens would just be to make this so, right? You're going to say that this is true, this is yes, and then you're going to simplify the movements of the heavens, and you've got it all figured out, and you can move on to other things in life. Well, like I said, most of us, if you're watching this, you're probably a little further down in your life path. You've started to ask these questions, and we're searching through the scripture for the truth, and that's the only way that we can find it is going to be from the given word, right? Because we have limitations on what we're able to do. We can't go in and inspect the foundations of creation for ourselves. We can't be there, obviously, when everything is the origins of everything. So we've got to take it on the word, and we can put faith in the word. And right here we've got, this is a picture from a high altitude balloon right here, right? And we've got an image of the sun from a high altitude balloon. You see that the blue sky has been reduced to this very small band right here. And then everything, is still on the distance of your horizon. This horizon never changes. Whether we go up or down, we've always got this horizon, this point. And in our study of Israel, we're going to call this this is Reuben, right? The border of Reuben, and Zebulun, the haven for ships. What kind of ships? Well, old world, you had ships of the water, but new world, we've got ships of the air, right? Planes and stuff, the exalted. And we would think of that as sort of the troposphere, right? So Reuben would be right at sea level. That haven for ships, the exalted ships would be like right up above it, Zebulun. And then, of course, Issachar would start to be that place of the sun and the moon. You're starting to understand, the donkey, the material, where that's being manifested. And then the highest point, the apex, would be Judah, right, in our breakdown of Israel. But as we're seeing this right here, we, through our study or empirical studies, in the breakdown of the elements, we're going to have this periodic table right here. And we're going to break all the elements down and understand that we have hydrogen and we have helium. We have these inert gases right here. So we have they're grouped in the types and then the periods, right? Periods and then groups. So some of these groups have similar attributes. So our inert gases right here, these 6, they're all going to behave the same, right? They don't interact with elements around them, and so these are good for, such as in welding, we've talked about, where you're insulating something and keeping it from burning. So your metal inert gas welding, you're going to use this inert gas right here to shield your weld, to keep it from exploding, to stabilize that weld joint. And then, these are also used like a neon sign. We're going to use these to illuminate. These will illuminate when ionized. And of course, we've got these few gases. Argon, essentially, this is going to be your heaviest element, and that glows blue. And then helium would glow more yellow up here. So when we think about what the sun is, a ball of gas, we would be thinking up here in the thermosphere is where the sun would be being produced, and then it would be a layer of atomized or atomic level hydrogen insulated by atomic level helium. And so when we think about the Lord, which would be sort of this, the Lord reigneth, is clothed with majesty. The Lord is clothed with strength, and is girded, and the world established that it cannot be moved. Psalms 93:1. This was pivotal to help me understand and associate this with your Adam and Eve, right? So Adam would be sort of your majestic plane, your vertical plane that's sort of dividing the potential of night and day, side to side. Eve, Hava, is literally a fence and a window in your Hebrew term, but that's going to be your material. Mother Earth, Father, Heavenly Father, but yeah, your Mother Earth plane, and we're separating everything out by density, right? So the material plane, we know that we have this separated out by density into layers. So we have the heavens. I've talked about this with the. I've got a tablet of Shamash video over here. That we talk about this a little bit more. You see this in the tablet of Shamash, the separation of night and day, above and below, creating your quadrants, your potential for the sun, potential for the moon, and then your neutral quadrant where you're getting sort of you can see the stars, right? Your nighttime, so your potential for your cloudy, your daytime, and everything. And you're sort of seeing this in this tablet of Shamash. You look at it as a disc, a vertical disc and a horizontal disc, and then there's this sort of rest point in the center, and you're looking at these quadrants. And these figures are trying to show you the different phases of matter, with sort of the light element in the physical matter, as well as the great light element that separates side to side here, the great Shamash, who creates the sun and the moon and your stars and everything else. Now, light, people associate that with illumination. That's a bit of a mistake. You're going to want to go look at Ken Wheeler's work. But light, I think we could think of more appropriately with the flux of sort of the magnetodielectric. But again, not to think that just magnets, because all matter will have this sort of effect. It's just only if it's got a great disparity can it actually influence or affect the environment around it. So reconstruct light and the flux of everything that's happening here, and then assigning this cross, the pinning of the hands, the Yod He Vav He, right, separating potentials for night and day and above and below. So once we have that down and understand what it's talking about with the Lord and how this is sort of being produced, well, now we can start to think of what's going on in these layers. So if this bridegroom, so to speak, so if we think of this as the Hava, or the Eve, the female half that's sort of dominating or creating the stratification of the material layers of creation here, with the earth plane, and then your open firmament above with the layers, and then now you're pinning this other hand, which would be sort of the male aspect, the atom. And so when we pin these together, when we overlay this, we see that we get sort of this this effect where you're going to have this positive element. Now this element right here, we would think of this being indexed. So you got this indexed at 23.5 degrees, and then if it's rotating, 47 degrees either way or whatever, essentially this would be pushing this union place right here, but it would be doing it at an even level right here. It should be more kind of even level across the highest sort of reaches of the hydrogen, because you would think that the hydrogen and helium are going to stay in a layer here. So as this and the material is fixed and stationary, so as the light element, the atom here, is turning and rotating, and you're getting your daytime side and your nighttime side. You're getting a sort of neutral pocket, and then your chamber, positive chamber that's rotating, and of course these are rotating at different speeds, and this would be sort of your dielectric moon chamber. So magnetic dielectric lights, hot and cold. So, but anyway, over the course of the year, this would be getting pushed out and in, and creating sort of that effect of your analemma. So, with this concept of essentially how this would be happening, essentially you think of this Lord as the thing that's creating the pocket, and we see this in the tabernacle. So if we want to look at, again, I would recommend everybody to Andrew Hoy's work of the tabernacle. Instead of this rectangular structure, we're thinking of this domed structure that has a cubit diameter of 314 and a diameter of 100 cubits and a circumference of 314. I guess I'll zoom in here a little bit on this so you can see it better. Maybe that was too much. Go to 100. Where did we go? Okay, here we are. So we had a breadth of 100 cubits and then 50 all around for your dome structure. So we're abandoning this rectangular model and applying this. Now there is tents and tabernacles, so there is two different aspects to this, and I'll see this a little bit differently, but it is interesting that you're going to find that we have a 100 cubit with 314 circumference of your primary here, but then it's also the inner curtains it's going to be telling you is 140 per side, so it's 280 in total. But you'll note that if you do make this arc length of 140 even with this 100 cubit diameter length, that requires when you do the math on this, it requires a 51 cubit radius. So interesting, and that's going to end up leaving 9 cubits out here. So it's interesting that if you take 51 and you apply Kepler's law and you're going to cube this and get this factor or this number, and then you're going to take the square root of that to get your period length, and you're going to get, so 51 associates to 364, so that would be like a star pattern number. And then your 9 out here, again, if we do this, cube it, and then the square root to get your period length, you're going to get 27. So that would be sort of your moon sidereal 27, and then your star pattern. So it is interesting that in this sort of tabernacle you are finding that value. But anyway, this would be your top-down sort of idea of the tabernacle. The tent, the circular tent with this tabernacle would be sort of a Pisces type thing that's happening. This intersection of these two halves, the male and female chambers. So above you would have this sort of meeting place inside this tent, and then so your side view, you would think of the sort of tent that would be happening, which would be shaped by your again, it would be sort of shaped by this concept here, right? You're shaping this, the flux of this, and you're sort of tenting into this particular layer, and then at the very top of this you would have your hydrogen, and then layered by your helium, and then these would be all your other kind of layers of the atmosphere. But you can kind of get an idea of how that positive ionization is creating that sun, and it's sort of slipping through the material. So this would be turning, and it's slipping through the material like a net. So it's almost slipping through like a net, and it's just continuing to move that node point as it goes around. So what we want to look at now is we're just going to look at the sort of how that's moving. So we got kind of a concept of what would be happening, of the sun being up there, how it's being formed, and how it's getting pushed and pulled just by this indexing of the Adam, the turning of the majestic, and it's how it's sort of pushing that node back and forth in that layer, that thermosphere layer, and just like I said, creating that instance of the sun. So now, how do we see? We want to look at how we see the sun, and we measure it sort of in this analemma. Now I had that other video where we were talking about sort of this idea of your tropic circle, your equator, and your tropic of Capricorn, Cancer, and equator right here. And so when we kind of try to think about this motion, essentially you're trying to find the middle point of these two circles. So you know that the sun is eventually going to be at one limit and the other. And we know that the mean distance of this is the equator. So the middle point is the equator. And so what we can do with this is, with this type of view, we just take this equatorial circle, we shift it over so that it's going to hit our limit points right here, and then we can get an idea of when it kind of would be crossing both the equatorial circle, and then what I did recall is we put this, we traced this analemma. So I found this video of an analemma that was taken in San Diego, I think, area, which was 33 degrees north latitude. And I traced that sort of figure 8 and then just kind of plugged it in here. So then we took this, and then we can use this, our software here, and we just can rotate this by 15 degrees at a time, and then we're just going to create a sun icon, and then we intersect it right there, right where our circle right here is. We rotate this, we're just going to put that sun icon so that it intersects, and then we create this sort of animation right here. So what we're doing is we're looking at the sort of the circle, the potential place for the sun, and then we're rotating this to kind of get an idea of the where it would be based off of where we know the sun is on this picture. And this picture we're taking at the same time every day. And so what we see is we start to get the sun icons are closer together here, and by the time we get to our other limit, they're further apart. And so this has given us an idea of sort of this inside-outside shape for one, but it's also kind of given us an idea of, we're slower moving over here when we're towards the inside, and moving faster, covering more distance on the outside. And so it's kind of helping us conceptualize the movement of this, but this doesn't help us with sort of the day by day, because we know that the sun is moving daily around this at this distance. So if it's getting pushed out, obviously our circle is going to be larger until we hit our limit, and then it's going to start getting smaller until we hit our limit, and it's going to go back. So we want to think, how is that happening? Well, so we want to look at the sort of epicycle concept here. And so we have our daily rotation, which again, the mean average is going to be the equator right here. And so we think of the sun moving all the way around on this circle. If I guess I'll zoom back out to 50 here. So we want to think of the sun sort of moving on this whole path right here would be the equator. And then the limit here would be our inside tropic of Cancer, and then outside tropic of Capricorn. So if we're going to use the Ptolemy idea is, we're going to be doing this sort of epicycle. So daily, as we're making this daily movement out here, where it's going to take us a tropical year, to make this rotation all the way until we hit our limit, all the way to the inside, and then we're going to make our way all the way out to limit out here, and then eventually we're going to get back to where we started at this equinox. So equinox, and of course this would be your spring equinox, this would be your summer solstice, fall equinox, winter solstice, and then back to spring. Now obviously when we do this, we're gonna cut this circle in a way. We're gonna cross at the very center of our epicycle circle here. But you know, I started to wonder, like, what is the mathematics? How do we figure out what percentage of the circle is inside and what percentage is outside? And I ended up going through a whole mess of you know, mathematics here, intersection of two area circles, and then I ended up finding that this this distance right here, you know, I applied these formulas right here. Some of the math really didn't. I don't know if I'm just not sharp enough on my trigonometry anymore, but I did find that this distance, this D1 distance, which would be the distance from your center here to essentially where you're going to measure your vertical Pisces right here, was 225. So that ended up being 225 again, which was interesting that we hit, you know, because, you know, our 233, you know, I put these in terms of our terms from biblical terms. Again, this we can figure this 90-degree piece right here is one quarter of the circle. So we figure this, we measure this in 90 degrees latitude, which is a quarter of our total circle, however we want to look at it, whether it's a polar projection or a global globular projection. Either way, this 90 degrees latitude is one quarter of either the circumference or the diameter, however we want to look at it. So, and that quarter again was 151,450, 151,450, and then remember that our Judah south portion that we found that got us at 23.5 degree relative was 39,650, and so both of these terms are divisible by 650, and so we can simplify this. Again, we talked about this in that astrolabe video. But we can simplify these to 233 and 61. And this, again, was helpful because our pi, you know, our pi approximation was 732 divided by 233, right? So if we were to divide this by 233, we're going to get our pi value right here. And this helps us because 732 is equal to 61 times 12. And so we find both of these figures right here, and it's easy for us to simplify this, right? So if we were to multiply our 90 degree, essentially our radius, which is 233, times 2 pi to get the circumference of this 233 radius, we're going to find that it's going to be 233 times pi times 2 is going to be 732 times 2, which is going to be the same as 61 times 24. And so this 61 portion right here, which is the radius of this circle, it's equal to an hour, right? So this is going to be equal to 1 hour of our daily rotation circle right here. So when we think about this sort of the daily rotation, or how far we've gone off of from the mean center of this daily rotation, we're an hour either way. So we're an hour in, we're an hour out, we're an hour advanced, we're an hour behind. So that's one interesting about sort of the mathematics of how that works out with those biblical numbers. But getting back to the concept of what's happening here, like I said, this is more in line with Ptolemy's system, even though he thought that the Earth was spherical, stationary in the center. We're thinking it's planar. And then, like I said, the heavens are moving in this different way, but getting pushed further in and out. So it's we would be thinking of that other sort of indexed rotation from that other plane happening with the rotation, our daily rotation. So these two basically circular motions are what's creating this motion for the sun. Now we've got a shorter distance to cover on the inside. I think I calculated this at 165 degrees right here is what I kind of rounded it off, 165 to 195. So you would think that, if you're moving 165 degrees on the inside, 195 on the outside, then, if this was just steady, even, rotation, then, we should not have a longer spring and summer season on the inside than the winter and fall on the outside. Why is it different? Well, obviously we're moving. You got to be thinking that we're moving in our daily rotation constantly in this easternly direction. So as we're making this rotation, we're moving against the grain for this half of from this equinox to the other. We're moving in the opposite direction, and then this direction we're moving with it. So you're moving with the direction of the daily rotation here, and of course this would account for your faster moving and then slower movement, right? But how does that account now for the fact that you have an equal amount of time when you get to the solstices, though? You have an equal amount of time on either side. Well, you got to remember that it's balancing out. It's got to do with the distance at which you're seeing this. So the distance, so if we look at this analemma right here, and so this is going to be, if we were to think of this at 0 degrees latitude and you look, that means that the sun analemma would be directly overhead. So you would be looking directly up at 0 degrees latitude, and you would be looking to our right would be to the inside to the north, and to the left would be the south. And so we would be tracking this as it would move sort of over the course of the year. It's going to be moving in such a fashion like this, where it's moving down, dropping in altitude to our left and right off of the apex, the center. But if we're all the way to the north or all the way to the south, say we're all the way 90 degrees north, so we know that anything that we see on our horizon, anything that's higher up in the air is closer to us, and everything that's further down, closer to our horizon line, which would be down here, everything that gets closer to our horizon line gets further away from us. And so when we're looking, like, say this is all the way north, as far as you can get north, your analemma view would be vertical. The apex here would probably be like, 23.5 degrees altitude is where you'd be seeing this at the highest. And then, your lowest point out here, you're going to hit the maximum distance before you actually hit the end of your analemma here, so you wouldn't even be able to see it. You'd have total darkness for a stretch. So yeah, you got to remember that the distance that's gonna factor into how you're seeing this analemma as well. So there's you gotta figure both of these motions. If you're in the south and you're at the other way, right? Obviously, the northern part here is going to be further away from you, and the southern part is going to be closer to you, so you're going to be seeing it in this other fashion. So it just depends on, obviously, if we rotated this up to, say, we put it 45 degrees here, we know that this is 45 degrees north latitude, because the northern part of our analemma here is higher from our horizon, so we know that we're in the north. If it were like this, 45 degrees the other way, we would know that we're in the southern hemisphere, so to speak. So put this back like this. So yeah, I thought this was kind of interesting. I would just put it in this other sense of thinking of the movement of the sun happening like this, with the again, like I said, you're fighting this daily rotation, And like I said, it's the distance. Like the distance, that point at which you're hitting this crossing right here, this is happening at 9 degrees north latitude. But the actual day, if we were to look at how many days it takes, so the equinox here for spring is happening on the 20th of March, but your analemma crossing is happening on April 15th. So that's 26 days. 26 days after your crossing here is when you're crossing your analemma. And so when you cross the analemma, that's when, like say, your date, your noon time for your whatever your meridian that you're on, that's when it's going to be crossing there. So it's going to take X amount of days, 26 days, which would be equivalent to about that number of degrees. Not much different than your 23.5 degree inclination there. But anyway, yeah, so it's going to happen, what was it, 26 days. So after your equinox here is when you're going to hit your analemma crossing. And again, this has to do with distance too, right? So it's going to be, the combination of distance and this joint speed of the daily rotation and this yearly rotation together is what's creating this variation off of your mean time, which is going to be, say, your noon time. So again, you're going to hit you're going to hit 4 times. You're going to cross here at the analemma crossing. You'll cross one other time, I think, out near your solstice or whatever, whenever it crosses out here. Like I said, this isn't a very good, obviously isn't a very good drawing, so it's going to happen a week before your solstice. So this would have happened a week ago when the sun would have been equal to our noon time. It would have happened right at noon a week ago. And then we're going to have our solstice, and then we're going to have our analemma crossing back going this other way on. The next time it'll happen is the 1st of September, which is 3 weeks before the fall equinox, and then so on and so forth, right? We're going to have our equinox and then move all the way out to our winter solstice. So anyway, this should help maybe clarify some things on some of these cycles again, and then that people get hung up on the tropical versus the sidereal and the precession of equinox. Well, again, the stars are moving faster than the sun. They're all moving in this sort of clockwise daily rotation, but day after day, the stars are just inching, 1 degree per day, moving ahead of the sun. And so by the time you get all the way out to, you hit your year mark, these have advanced all the way. And like I said, these are there for signs and seasons so that we can understand, we can understand when the sun has actually moved into, constellations that are in here, because it's going to be making this sort of serpentine motion over the course of the year. But yeah, like I said, it's going to be moving falling ever so slowly back from these stars. So by the time you get all the way around to your year mark here, by the time you get back here to your year mark, you might be, and you're looking at your equinox, well, you might just be a little bit further ahead. I didn't mean to do that. You might actually be a little bit further ahead of the stars. So even though you're falling back a little bit every day, by the time you hit your tropical year, you're actually probably a little bit ahead of where you were at before. So people look at that as the precession of the equinox, right? Because you're going to be advancing. It makes it look like the sun is advancing on the stars, but continually, day after day, it's falling back from the stars. Even though the snapshot that you take at the end of the year, it looks like you've advanced. So anyway, that's sort of the movements of these luminaries as I see it, and kind of why you're going to end up with some of these different times. And I'm sure there's some mathematics involved in there, but yeah, I definitely think that it's happening based off everything I'm getting from the biblical it's sort of just pushing this back and forth. And so the Levitical laws and all that, I think it's got a lot to do with this sort of separation of clean and unclean and all of this trespass offerings, sin offerings, all this kind of stuff. And then with all of the laws of male and female and everything, I think that's what it's talking about. It's got to do with this sort of movement. And then that should help clarify people too on sort of the concept in my head of like, because you might be looking at the number studies, like that encampment and how I'm coming up with those numbers. Well, it's got a lot to do with this cosmology. But like I said, you're going to have to incorporate a lot of this empirical sciences, physics, chemistry, mathematics. The culmination of human effort is going to be understanding how our temple, our shared temple here, is constructed, and really, the full praise to the Creator, and understanding this Lord, which is the instrument of creation, that's really creating all these things. And you can't just put one thing highest. You got to kind of put it all together. But at any rate, hopefully you enjoyed that. Hopefully that made sense, and we'll see you on the next one. Thanks.